Hi guys, here's your video that goes over the notes for 6.2 trigonometric equations. So what we're doing in this video is solving trig equations. Now before we actually get to the equations, there's a couple things you need to pay attention to. One of them is the hand trick, which will give you the ordered pairs in the first quadrant, and another thing you need to pay attention to is the signs of the ordered pairs in all of the quadrants. So I'm going to go ahead and jot down all of the ordered pairs in the first quadrant, and I'm going to refer back to this as we go through our notes. So this is your first quadrant. We have 0 radians. Up at the top is pi over 2 radians. We can split that in half. That gives you pi over 4. And then we also have pi over 6 and pi over 3. Now all of these angle measurements are going to be in radians, so please get familiar with the radian measure and their corresponding ordered pairs. So your ordered pair at 0 is 1, 0. At pi over 6 is root 3 over 2 and 1/2. You can just look at your hand for that. Pi over 6 is your index finger. Pi over 4 is root 2 over 2 and root 2 over 2. Pi over 3 is 1/2 root 3 over 2. And pi over 2 is 0, 1. The other thing you need to pay attention to are the signs of all your quadrants. So I'm going to go ahead and draw out the rest of the quadrants. So in the first quadrant, your ordered pairs are positive, positive. Second quadrant, your x is negative, y is positive. Third quadrant, they're both negative. And fourth quadrant, x is positive, y is negative. Okay, so I'm going to refer back to this slide as we go through the video. So here's our first example. So the first example, we're looking at sine of theta equals 1/2. So instead of finding the 1/2 when I give you the angle, I am giving you what your sine equals, and you need to find the corresponding angle. So the first thing I want to do is actually draw where sine would be a positive 1/2. So sine is positive in your first two quadrants, because sine is your y-coordinate, and your y-coordinate is positive in those two quadrants. So the two angles that we're trying to find, we are trying to find this one and that one, because it needs to be a positive angle, so it starts on your positive x-axis and goes counterclockwise. So sine is 1/2, which means your y-coordinate is 1/2. So I'm going to go back to the other slide to see all of my ordered pairs. I need to find an angle where my y-coordinate is 1/2. That's pi over 6. So that is the reference angle, these two measures right here. Okay, because your reference angle is that wedge against the x-axis. So this is pi over 6. And this wedge is also pi over 6. Now keep in mind the angles that you're trying to find are positive angle measures. So you're trying to find this one like I drew before, as well as that piece. So the first angle measurement is pi over 6. And my second angle measurement is I'm pi over 6 less than pi, so that puts that second angle measurement at 5 pi over 6. Now if you read the directions say to find all of the solutions of the equation, so it's not just going to be limited from 0 to 2 pi, we need to find all of the solutions. So there's actually an infinite amount of solutions that can work for this, because I can keep going around, so let me draw this. So I can start right here and go around a full rotation. That's still going to give me that y-coordinate being 1/2. I can go around again, and I'm still going to have that y-coordinate be 1/2. So I can keep going around and around and around, and you can still have sine of that angle being 1/2. So the way that we write that is you are going to add a 2 pi n to both of those solutions. So the 2 pi n will allow us to add infinite rotations, infinite full rotations, to get all of the solutions. And it's also 2 pi n because the period for sine and cosine is 2 pi. So there are your two solutions for letter A. It's not always going to be 2 pi n, it just depends on your scenario, but for sine and cosine it will be 2 pi n. For letter B, we need to start by isolating the trig function first. So I have cosine of x equals negative root 3 over 2. So my cosine is my x-coordinate is negative in your second and third quadrants. Okay, so I'm going to go back to my other slide to find when my x-coordinate is radical 3 over 2. Not negative, because I know that it's negative because it's in the second and the third quadrant, but we're just going to look at the reference angle to figure out what your wedges are. So again, we're looking for when your x-coordinate is root 3 over 2. That is pi over 6 again. So this wedge right here is pi over 6. This wedge is also pi over 6. So now I need to figure out what those two angles are. We need to figure out this one and that one. So if you keep in mind that we are in sixths, that means pi is 6 pi over 6. So your first angle measurement is 5 pi over 6. And your second angle measurement is pi over 6 past pi. So that's going to be 7 pi over 6. And then don't forget to add your 2 pi n so we can account for all of the solutions. And there you go. Equation solved. Alright, let's do some more. So the next one we're looking at is cosecant. So cosecant is the reciprocal of sine. So instead of looking at cosecant of theta equals root 2, I'm actually going to look at sine of theta equals 1 over root 2. It needs to be rationalized because everything on the unit circle is rationalized, so that gives me root 2 over 2. So sine is positive. So sine is positive in these two quadrants. So I need to find when my y-coordinate is root 2 over 2. So I'm going to go back to this. My y-coordinate is root 2 over 2 at pi over 4. So your reference angle is pi over 4. So that makes this wedge pi over 4. This wedge is also pi over 4. So your two angle measurements, you have this one right here, which is pi over 4, and that one. So your first angle measurement is pi over 4. Second angle measurement is pi over 4 less than pi, which is 3 pi over 4. Don't forget to add your 2 pi n for all of the solutions. So if I give you the reciprocal function like secant or cosecant, go ahead and rewrite the equation in terms of the regular trig functions like sine and cosine, and then just solve just like the rest of them. Alright, tangent. So tangent is negative in the second quadrant. It's also negative in the fourth quadrant, but I'm actually not going to draw that angle, and I'll explain why in a little bit. So tangent is your y divided by your x. So let's go back to the slide with all of the ordered pairs. So if looking at pi over 6 and I take my y divided by my x, I don't necessarily have to pay attention to all of those being over 2, because your 2's are going to cancel in the end. So I can just divide the numerators. So for pi over 6, the tangent would be 1 over root 3, or root 3 over 3. For pi over 4, I have root 2 over root 2, so my tangent is 1. For pi over 3, I have root 3 over 1, which is just root 3, which is exactly what I'm looking for. So our reference angle is going to be that pi over 3. So this wedge right here is pi over 3, which makes that angle 2 pi over 3, since it's pi over 3 less than pi. So you're taking away pi over 3 from pi. Now before you're too quick to write down plus 2 pi k, let's talk about tangent. So if you think back to your graphing of tangent, the period for tangent was not 2 pi. The period for tangent was pi, because tangent repeats more often than sine and cosine do. So instead of adding 2 pi n, I'm going to add just pi n, because that's how often tangent repeats. So there is your solution for your tangent equation. So your tangent equations will always just have one solution plus your pi n, while the sines and cosines will always have 2 plus 2 pi n. Now let me explain why I didn't draw the angle in the fourth quadrant. So thinking back that tangent has a period of pi, that means it repeats every half rotation. So if I am starting right here and go around half of a rotation, that gives you that solution in the fourth quadrant where your tangent would be negative. So that's why you don't need to draw both of them for tangent. You can just draw the first one and then plus your pi n. All right, so still solving equations. This one you have two expressions being multiplied by each other where it equals 0. So for this you're solving by factoring. So I'm going to go ahead and set both factors equal to 0. So I have sine of theta plus 1 equals 0. And then cosine of theta minus root 2 equals 0. So instead of having just one equation like we had for all the other problems, now I have two equations. For both of these, I'm going to go ahead and isolate the trig function and solve just like we solved with the other equations. So for the first one, I am looking at sine of theta equals negative 1/2. And for the second one, I am looking at cosine of theta equals root 2. Now if I draw my angles for my sine, your sine is negative over here and over here, so in your third and fourth quadrant. You can go back to that slide that has all of your ordered pairs in that first quadrant. So sine is 1/2 at pi over 6. So that makes this angle pi over 6. And this angle is also pi over 6. I don't know what I'm writing right there. Pi over 6. Okay, so here are the two angles we need to find. We need to find this one and that one. So your first angle is pi over 6 units past pi. So that is 7 pi over 6. Your second angle is pi over 6 less than 2 pi. So that is going to be 11 pi over 6. And then don't forget the plus 2 pi n. Now for the second equation, cosine of theta equals root 2, if we go back to the first quadrant, you don't have any x-coordinates that would give you a root 2. So this equation actually has no solution. Now, it doesn't have a solution because you can't actually find it in the first quadrant because there's an infinite amount of ordered pairs in the first quadrant. It really has no solution because root 2 is greater than 1, and sine and cosine have a limitation of -1 and +1 because it has to stay in between those two values. So that's why it really has no solution, not because you can't find it in that first quadrant. So really your only solution for this equation, since you were multiplying those two expressions, is that over there with the 7 pi over 6 plus 2 pi n and the 11 pi over 6 plus 2 pi n. Okay, so this covers all of the notes for day 1. I'm going to go ahead and continue into day 2. So day 2, we're still solving. It's just that now, if you'll notice, inside your trig function is not just x or theta. We now have the expression x minus pi over 3. So I'm actually going to treat this as if it were just sine of theta equals -1. So -1, if we graph it, sine is your y-coordinate. Your y-coordinate is -1 down here, and so the measure of that angle all the way around is 3 pi over 2. So that gives me theta equals 3 pi over 2 plus 2 pi n, just like we were doing with day 1. Now we weren't actually solving for theta, we're actually solving for x minus pi over 3. But if you'll notice, I replaced this with theta. So what I'm going to do now is I'm going to rewrite this as x minus pi over 3 equals what we solved for theta, being 3 pi over 2 plus 2 pi n. Now we want to get x by itself, so I'm going to go ahead and add pi over 3 to both sides. So plus pi over 3 plus pi over 3 over here. And that gives me x equals 3 pi over 2 plus pi over 3 is 11 pi over 6. You can use a calculator if you struggle with the fractions, plus 2 pi n. If you'll notice, I didn't add the pi over 3 to the 2 pi n because you're really just combining like terms, and pi over 3 is just some number, just like 3 pi over 2 is just some number. X is a variable, and 2 pi n also has a variable, so you can only combine your numbers with other numbers. And that is your solution for this problem. Let's do another one. So I have cosine of 4x minus pi over 4 equals root 2 over 2. So cosine is positive in your first and your fourth quadrant. I'm looking for my x-coordinate is root 2 over 2. That's at pi over 4. So that makes this wedge pi over 4. This wedge is also pi over 4. So instead of having theta equals, I'm going to go ahead and write the two equations. I have 4x minus pi over 4 equals, my first angle measurement is this one right here at pi over 4. So this will be pi over 4 plus 2 pi n. And I'm going to write it again, but again, instead of theta equals, I'm going to write 4x minus pi over 4 equals my second angle, which is going all the way around to the fourth quadrant, and that is at 7 pi over 4 plus 2 pi n. So again, I didn't do theta equals, I did this equals, because essentially you're substituting that in for theta. Okay, so now I'm going to go ahead and start solving for x. I'm going to add pi over 4 to both sides. That gives me 4x equals pi over 4 plus pi over 4 is 2 pi over 4, or pi over 2, plus 2 pi n. I'm going to do the same thing over here, plus pi over 4, plus pi over 4. That gives me 4x equals 7 pi over 4 plus 1 pi over 4 is 8 pi over 4, or 2 pi plus 2 pi n. Still need to solve for x, so I'm going to divide everything by 4. So that gives me x equals pi over 2 divided by 4 is pi over 8, plus 2 pi over 4 is pi over 2, n. And that gives me your first set of solutions. And the second one, going to divide everything by 4. So I have x equals 2 pi over 4 is pi over 2, plus pi over 2 times n. Now if you'll notice, when I divided by 4, I divided everything by 4. Because when you multiply or divide by something, that goes to everything. But when you're adding or subtracting, you can only do that to like terms. So there are all of the solutions for this particular problem. Alright, so now instead of finding all solutions, we're only going to find the solutions that are in a particular interval. So I'm going to go ahead and start by figuring out when my sine is 1/2. So sine is 1/2 in my first and third quadrant. Sine is your y-coordinate. Your y-coordinate is 1/2 at pi over 6. So that makes this pi over 6, makes this pi over 6. So your two angle measurements are pi over 6 and 5 pi over 6. So I'm going to go ahead and set up the two equations like we did with the last slide. So I have 2x plus pi over 4 equals pi over 6 plus 2 pi n. And then my other equation is 2x plus pi over 4 equals 5 pi over 6 plus 2 pi n. I'm going to solve both of those for x, so I'm going to subtract pi over 4 from both sides. Same thing over here. Going to subtract pi over 4 from both sides. That leaves me with 2x equals, let's see, 1/6 minus 1/4. Let's bracket. That gives me negative 1 pi over 12 plus 2 pi n. And then this one over here, I have 2x equals 5/6 minus 1/4, bracket, 7 pi over 12 plus 2 pi n. And now I'm going to divide everything by 2. So I have x equals negative pi over 24 plus pi n. And then this one I have x equals, oh, forgot to divide by 2. I have 7 pi over 24 plus pi n. But wait a minute, the solution, or the question didn't say to find all the solutions, it said to find the solutions in the interval. So now we need to figure out which of these angles are in the interval. So negative pi over 24 is not in the interval from 0 to 2 pi. Now I'm going to go ahead and write this 2 pi in terms of 24ths, since our fraction is in 24ths. Whoops. I totally just used the calculator to multiply 2 times 24. It's been a long day. So this is going from 0 to 48 pi over 24, because I want it in terms of 24ths since my fraction is in terms of 24ths. So this is the interval that we're actually working with. So I'm going to start with negative pi over 24, and I'm going to go ahead and add pi n. So I'm going to do negative 1 over 24 in the calculator plus pi n, which is just going to be 1, because you don't want to put the pi's in, because that's just going to not give you things that are frackable. So here's our first solution for x. That gives me 23 pi over 24. And I'm just going to keep adding 1, since you're adding pi, until I can no longer be in the interval up to 48 pi over 24. So if I add 1 again, my next one is 47 pi over 24. If I add 1 again, I'm at 71 pi over 24, which is not in the interval because it stops at 48 pi over 24. So the 23 pi over 24 and the 47 pi over 24 give you the solutions for that. I'm going to do the same thing, but for this piece. So I'm going to start with 7 over 24. Again, I'm not putting the pi's in the calculator, otherwise you're not going to get something that's frackable. I'm going to add 1 pi to it, or just 1. So that gives me 31. Oops, it's a really bad 31. If I were to add another 1 to it, that puts me at 55 over 24, which is no longer in the interval. Now, before I added the 1 pi to it, I really should have just looked at that 7 pi over 24. 7 pi over 24 is in that interval, so that is also going to be a solution. If you look at the first one that I circled in blue, negative pi over 24 is not in the interval from 0 to 2 pi, so that's not going to be part of this solution. So don't forget to actually include that first angle measurement that you have. And these 4 together create your solution within that interval. Alright, so that covers all of the notes for section 6.2. I hope this video helps you understand the material. Alright, I'll see you in class.